Hi everybody. Today's video is about factoring with greatest common factors. So I've taken this equation and we are going to put it into factored form. The first thing you always need to look out for when you're trying to put a function into factored form is you're looking for greatest common factors. This is a simple way of putting certain equations into factored form without really having to do too much algebraic work. So the equation I have here is 6x squared plus 12x. So we are looking for greatest common factors between both terms to determine how we can put it into factored form. So when I talk about two separate terms, this right here would be term 1, and this right here would be term 2. So the way I determined that is the fact that there is a little plus sign right here in between the two. It could also be a minus sign. Those would be the same thing, but those actually divide up the terms. So anything going on in here is all multiplication division, right? The 12 multiplied by the x, that's all multiplication. But if something is added or subtracted, that helps determine your terms. Okay, so now that we've determined we have term 1 and we have term 2, let's talk about what we can do to them to put them into factored form. So when we're using greatest common factors to write out factored form, we need to determine all the factors of the two terms or multiple terms, and then we can divide it out. Okay, so what are the factors of 6x squared? Let's think about that. Let's start with the 6 alone without the x squared. We have 1 and we have 6, because 1 times 6 is equal to 6, and 6 times 1 is equal to 6. Okay, we also have 2 and 3. So we have 2 times 3 is equal to 6 once again. Okay, now we look back at our equation here. We also have x squared. In order to get x squared between two terms, what do we need to do? We need to multiply x times x. Because remember, x times x is equal to x squared. Just like 3 times 3 is the same thing as writing 3 squared. The same logic applies for this, okay? So if we have x squared and we're trying to divide up factors, that means there needs to be an x in each factor. So that means we would actually have 1x, 6x, 3x, and 2x for our factors. Okay, so those are the factors of term number 1. Let's move on to term number 2 now. What are the factors? Let's start with just the 12. Factors of 12, we have 1 and 12. We have 2 and we have 6, because 2 times 6 is 12, right? And then we have 3 and 4, because 3 times 4 is 12. Now we look at this one, and there is only one x. Therefore, it's not x times x is equal to x squared. It would just be x times some constant is equal to x, right? Any constant, so 12 or 6 or 4 or 1 or 3, it doesn't matter. But there's a constant, and then multiplied by x will get you some sort of value of x. It's a little bit different than the last one. So that just means that when we add our x's here, our x is either x is here or x is here. It's not on both of them, okay? But there will always be one x somewhere in one of these terms, okay? Great, so now we've determined the factors of the second term. So now what we need to do is look for the greatest common factor. So we're going to look through all of our groups of factors. We're going to find the largest one that's comparable between the two. So that's the same in both of them. So if I look at this one from our first term, I scan through this, and then I look at our second term, and I scan through that. What is the biggest number that is in common between the two? Looks like we have 6. 6 is our greatest one. Remember, this is 6x as well, and all of these always have an x. So therefore, our greatest common factor is not only 6, but it's actually 6x, because we can take at least one x out of both of these terms. We can't take two x's, because this one only has one x. This has two. There's only one we can take out of this one. So what I'm going to do then is I'm going to take 6x out of each term. So when I say that, I mean you're going to divide each term by 6x. So you're going to take 6x squared, which is our term number 1, and you're going to divide it by 6x. However you want to write it. If you want to write it like that, you can also write it like that, but I'm writing it as a fraction because that visually is better for some people. So what does 6x squared divided by 6x equal? Well, 6 divided by 6 is 1. We have a 1. And then x squared divided by x. This trips some people up once in a while. But remember, we were talking about how x times x is equal to x squared, right? So if we're doing the opposite, we're dividing, that means x squared divided by x should equal x, right? Which means 6x squared divided by 6x is equal to 1x. Now, whenever I get 1 in front of an x, I can just write x as well. Remember, because you have 1x, it's the same as just having x. Okay, so now that I have that, that means we have a spot for term number 1 right here. So I'm going to write that in. I'm going to write my x right in there for term number 1. Okay, now let's go back to term number 2, way up here, which is 12x. So now I'm going to do the same thing. I'm going to take 12x, but this time I'm going to divide it by 6x again. Remember, because that's what we're taking out. We've determined that's the greatest common factor we want to use. So we have 12x divided by 6x. Start with the constants. So you have 12 divided by 6, or the coefficients, I should say. 12 divided by 6 is 2. So we have 2. And then if you have x divided by x, that actually equals 1. Not x, but 1. So we don't write anything. We could write this, but we don't need to do that because 2 times 1 is also just 2. So now we know our constant is, or our factored out is 2. So I'm going to write 2 right here. And this is our second term. But we need to pay attention. We need a little symbol in here. We need a plus or a minus. Let's look. Originally, this was a plus sign, so likely that's going to stay. But also remember, this 2 was also positive. So let's keep our positive right there. Great. So now we just took 6x out of our original equation out right up here. And we put it outside the brackets, and inside here, we have the remainder. So that is now in factored form, and that helps you determine the x-intercept, which I will show you in another video.